All right, this is APBC calculus. We're doing midterm review. This is multiple choice number 15, which is a calculator problem. So f has a first derivative that we're given. What is the coordinate of the inflection point of the graph of f? Okay, so here's the thing. You could, and I know some of you are thinking this, some of you are like, why don't I just differentiate this and get the second derivative? But that is not the smart play here, right? So let's talk about what it means for f to have a point of inflection, okay? F has a point of inflection if f double prime changes sign, right? Like, so equals 0 and changes sign. So in order to change sign, f prime either has to be 0 or does not exist, but still. But here's the problem. I don't have f double prime, I have f prime. And I want to use my calculator in the best way possible, so I do as little math as possible. My job here is to connect the dots so I don't have to find the derivative of this ugly function. Well, f prime, right, or f double prime rather, is the slope of f prime changes sign. Meaning, I can find this value by looking at the f prime graph. So I graph f prime, which is given as y1, and I look for its extrema. Because if you think about it, let's say this is my f prime graph. If f prime does this, this must mean f double prime is positive because f prime is increasing, and this means f double prime is negative, etc., right? And if I go like this, then it means f double prime is positive. Those are spots that f would have a point of inflection. So all I have to do, like, I don't have to differentiate here. I just have to make the connection of how I would find this value. Now, you could differentiate. It's fine. It's a weird choice, but you could do it. I'm not going to because this is much, much faster. Oh, my bad. X plus, I'm hoping that's an x cubed, and if it's not, I guess I'll be redoing this video in a sec. All right, so cool. All right, so there's my function. That's my f prime. So when I graph this, now I'm not given a window, right? I'm not given a window, but I look at these x coordinates, and they're all between, you know, like -1 and 2, so I could probably zoom 6 and be okay. So let's try zoom 6. Okay, so I tried zoom 6, and it was way too small. That was a big mistake. So let's zoom in a little bit. Right, when you zoom in, you want to scroll to where you want to zoom in, which I'm going to kind of scroll to the top of this little blob I see. Hey, look, there you go. It's going to have to be at this spot. This is the only max. So if I do second calc max, if I go to find any extrema, right, and so I'm going to try and get the max here. 4.3 is bigger, 4.5. Oh, wait, 4.5, sorry, 0.435 would seem to be the biggest, so I'm going to go here to the left, go to the right, hit enter, and sure enough, this is where f prime, and I'm going to screenshot this and drag it over because I want to draw on this why this is what it is. At this moment, right, so this is y equals f prime, meaning that over here, f double prime is positive because f prime is increasing, and over here, f double prime is negative because f prime is decreasing. So this max value is my winner, and it's answer B. Now, you could have differentiated this. Absolutely, you could have done the quotient rule and found f double prime. If you found f double prime, right, like, so I'm not recommending this. So I'm going to go ahead and say that I think this is a bad idea, right? But if you had decided to find f double prime, right, f double prime would have been low, d high, and again, I'm going to like echo how I said this was a bad idea, minus high, d low, draw the line, square the low. You could type this entire ugly mess in your calculator, and it's disgusting, but you could absolutely do it, right? If you type this in your calculator as y1, right? So like, let's say you put this in your calculator as y1, right? So somehow you decide this is y1. Well, then if f double prime is your y, f double prime changes sign when your graph, right, your f double prime graph, which you're calling, let's say, y1, crosses the x-axis, which would be second calc 0, right? So instead of finding the max, you would find when this, and that's fine, you're going to get the same answer. I'm not going to do it because it's a terrible idea, and it would be much more work, but you could find it, right? You definitely could find it by finding the second derivative by hand, which is really tedious and awful, and then after you find the second derivative by hand, you could second calc 0 to find where it changes sign. Really not worth it in my opinion, just throwing that out there.